Hi friends, so today we are going to talk about thermodynamics. So this is first part of the lecture thermodynamics. In this topic we are going to talk about introduction of the thermodynamics, systems in thermodynamics, variables in thermodynamics and equilibrium processes in thermodynamics. So let's start. So first point is of course what is thermodynamics? So thermodynamics is a branch of physics that deals with relationship between heat and other form of energy. It helps us to understand how energy flows in a physical and chemical system, especially during the state of change or mechanical work. It also explains the macroscopic behavior of matter. Next is thermodynamic systems. A thermodynamic system is defined as a region in space where we analyze the energy interaction. Depending on what it exchanges with surrounding, we can classify it as open system that exchanges matter and energy with surrounding, for example, boiling water. Next one is closed system that exchanges only energy with surrounding. An example is gas in a sealed container. Third one is isolated system that exchanges nothing with the surrounding. For example, thermos bottle. Understanding these systems is a key to analyze the real world thermal problems. Thermodynamic variables. Thermodynamic variables are the quantities that describes the state of a system. For example, pressure, volume, temperature, and internal energy are interrelated through equation of state like ideal gas equation, that is PV is equal to nRT. Next point is thermodynamic equilibrium. When a system is in thermodynamic equilibrium, its properties do not changes with time. This happens when there is balance in force called as mechanical equilibrium. If there is balance in temperature, it is called as thermal equilibrium. And if there is balance in a chemical composition, it is called as chemical equilibrium. Key to understanding the stable system in nature and industry. Next point is thermodynamic processes. Thermodynamic processes describes how the system changes. Whether there is heat or work is added or removed in a system depends on whether the system is isothermal system. The isothermal system where temperature is constant, or adiabatic system where there is no heat exchange between system and surrounding. Isobaric process where pressure is kept constant, and isochoric process where volume is constant. There is one more process called a cyclic or non-cyclic process. It depends on whether the system will return on the original state or not. Let's take some numerical problems. So question 1 is, which of the following is not a type of thermodynamic system? Open system, closed system, isolated system and static system. So of course, open, closed and isolated systems are well-defined thermodynamic system, and static refers to a state and it is not a system type. So the correct answer is option D, static. Let us talk about second question. In a closed system, which of the following is true? Both matter and energy are exchanged. Only matter is exchanged. Only energy is exchanged. Neither matter nor energy is exchanged. So the correct answer is C. Only energy is exchanged. A closed system do not allow a matter to enter or leave, but it can exchanges energy like heat or work with surrounding. Let's take third question. Which of the following is a thermodynamic variable? Entropy, mass, temperature, and kinetic energy. Here the correct answer is temperature. Temperature along with pressure, volume and internal energy are defined as a thermodynamic state. Mass and kinetic energy are not core state variables in this context. Let's talk about question number 4. A system is in thermal equilibrium when A. Pressure is constant, temperature is uniform, C. Volume remains fixed, and D. Heat is continuously absorbed. So correct answer is option B. Temperature is uniform. See, in thermal equilibrium means there is no net heat flow within the system or with the surrounding, implying the uniform temperature. So the correct answer is option B. Okay, so let us take new question. Which thermodynamic process occurs at a constant volume? Isobaric process, adiabatic, isothermal, or isochoric? So obviously option is correct. Option D is the correct one. Isochoric process. The iso means state and choric related to volume. So hence isochoric means a volume is constant during this process. Actually, isobaric is a process where pressure is constant. Adiabatic process is the process where there is no exchange of heat is there. Isothermal, that is temperature is constant, and isochoric process is the only process where volume is kept constant. In next lecture, we will explore the zeroth law of thermodynamics, which lays a foundation for the understanding temperature, and dive deep into heat transfer, internal energy, concept of heat, concept of temperature, and thermodynamic system. We are also study about PV diagram and how they help to visualize this process. So if this video helped you, don't forget to like it and share it with your friends. Subscribe to the channel and hit the bell icon so you get a notification when next part of this thermodynamic series drops. See you in part 2, and remember, consistent revision is the key to success. Thank you. Take care.